Dear students, uh, this is the part 2 of the video for numerical relay development kit. So as you can see, this is the numerical relay development kit. Here, if you see the left top, you have got the display, and we have got one power LED and 4 different LEDs which can be programmed. We have 3 switches, S1, S2, S3, and 1 hardware reset key. Below, if you see, the leftmost is a USB connection to the computer. The next one is RS485 for event downloader, that means collecting data. Then RS232, which can also be used as an alternative to the USB. And finally, on the rightmost, you see here a factory port, which is for used by the manufacturer. Now, on the right side, on the top, the middle row, you see here we have test kit inputs, test kit outputs, and relay inputs. Now, what exactly this do? This get data from the computer, then convert that to analog form using a DAC converter to be used by the relay. There are basically 4 relays here, 2 normally open as you see here, and 2 normally closed. So if you see here, further we have got 8 number of ports. You see A1, A2, A3, A4, then A5, A6, A7 and A8. So we can program it. For example, we can have 3 voltage, 3 currents, and 2 ports are generally, as you see here, 2 ports are for A4 and A8. If you see, 2 ports can be spare. This can be used whenever required. So next, on the rightmost top right, you see trip timer. Then you have got these 4 relays, NO and NC. We can also directly give the digital inputs rather than from computer and use this kit. Okay. So now we will see what software we need. So these are the 4 main softwares that we are going to use. So the first one is NRDE event downloader, NRDE PC loader, and MPLAB X. First we will start with MPLAB X IDE, the integrated development environment, where the code will be there. We'll see the code. The PC loader application then will be used to connect to the NRDE kit to dump the code. And then we'll use NRDE software to create a fault and see the timer. And finally, NRDE event downloader can be used for downloading the various waveforms. So at first, we'll open this MPLAB IDE. So if you see here, you have got this IDE. You need to open the code. If you see here NRDE, you have to open a project. Then, or you can also go for file, new file. You can use your own code. In this case, I'll show you this code only. Okay. So let me open it first. Yes, it's already open. Okay, yes. So you see here the code. This is the embedded C code. These are all header and define files. Then here, this is what is relevant for us. The curve type we are using here is IEC standard inverse. Then the pickup current we have set at 1 ampere with TMS as 0.5. Okay, and further if you go down, there are code or part of the code where you will see how the various ports are programmed. So the point to remember is that our pickup current is 1 ampere. Now we are going to compile and build the code. So we have to compile it. Okay, then you can clean and build or directly build. Okay, so you see here there is a location where the hex hex file is uploaded. So I will show you that location. Okay, so if you see here, the hex file is located at this location. So I will show you that location where it is located. So if you see here, this is the location where you have got hex file which is just now built. Now that we have got the hex file, we will open the PC loader application. Before loading the code, first we have to take this kit into bootloader mode. Okay, so as you can see here, so we need to press the S1 key and then the HRST key. Okay, and if you see here, the LED 1 is blinking. Okay. So that means it has entered into bootloader mode. Okay, so after it has entered into bootloader mode, we need to use the PC loader application. Okay, so we will see the PC loader application. So if you see here, so this is the PC loader application. Okay, so with this we will connect. So now we have connected the device. Then we will load the hex file that we had created. Okay, so this is the hex file that we have created. So file loaded successfully. Then after that we need to click on erase, program and verify. Okay, programming completed, verification successful, and then we will disconnect it. And we close the PC loader application. So now we will open the NRDE application and we can go for trip time or transient analysis, but here we are going to obtain the steady state analysis. So we'll click on steady state analysis. So when we click on steady state analysis, a window will open. So this is the steady state analysis window. Okay, so if you see here, so here you have to give fault currents. So what you are going to do is, say we have given the set current to be 1 ampere. So we will use IA 0.5 ampere and run this. Okay. So in this case, the relay is not going to trip. Okay. So for long time, relay won't trip because our set current is 1 ampere. Then we'll stop this, do a hardware reset. Okay. So relay did not trip. So we'll give some current, say here we'll give 1.5 ampere and we'll run it. And we will wait for the relay to trip. And once the relay trips, we'll do a hardware reset. Okay. So after that, we will do hardware reset and give 2.5 ampere, run it and wait for the trip to happen. Okay, so it is tripped now. So accordingly, we will continue the tripping up to 10 amperes. So we have already recorded it and I will show you. Okay, so you see here. So first, when it was 0.5 ampere, the relay did not trip. Okay, you see. So here, first case relay did not trip. Next we change the current. So you see here, it is okay. This is the 0.5 ampere case. Just look at the display. Now it is 1.5 ampere case, and all the information is displayed here. And if you see, the initial currents will take some more large time. It is based on this inverse characteristics. So we have to wait for some time. Yes, it tripped. So it is 0.513 seconds. Then we have to do hardware reset again. And we gave 1.5 ampere, if you remember, 2.5 amperes, if you remember, yes, 2.5 ampere. Then now the relay will trip faster. Okay, see, 3.7 seconds. And again, so it continues. Now the current is 3.5 ampere, 2.74 seconds. The time of trip is reducing constantly, 4.5 amperes, 2.2 seconds. Yeah. Then 6.5 amperes, 1.831 second. Remember that you have to always press the hardware reset key after the tripping has been done and LED 1 is on. Remember that we have programmed, in the program itself we have used LED 1 as a trip indicator. You can also use LED 2, 3, 4 as the trip indicators. So as the current progresses, the relay trips faster. Now we have reached 8.5 ampere current, 1.598 seconds. Nine ampere current, 1.55 seconds. 9.5 ampere current, yes. 1.517 seconds, and finally okay. So with this we have got several current values and the corresponding time values. You need to plot that. You need to get the data entered in some software and plot it. So you will get a inverse characteristics. The final step is obtaining the data using the event downloader software. Okay. So now we have opened the event downloader software. If you see here, you have to select a particular location. I have selected on the desktop, and you have to use the port that you have where the data event downloader USB is connected. In my case, I checked that it is COM8, so you can check that from your device manager from your in your computer. Now we click on download. Okay. Now sometimes the data is not it's deleted, so it is faster. In that case, you have to check again. You have to do the fault simulation again. Okay. So we'll download. See, now since the data is available, so it takes some time for this to download. Okay. So if you see here, still the data is getting downloaded. It takes a while. If it is done very fast, that means your data is somehow deleted by the hardware reset. So you need to induce the fault again. Okay. So now I got a message, event download completed. So I will just show where we have downloaded. So if you see here, there are two such event files which are downloaded. Okay. We'll just try to refit. Okay. So if you see here, this is the event downloader. So let's see the event. So if I click on the waveforms, you see there are so many information. So it depends actually on your channel. So these are channel 1, 2, 3, which are for voltages. Then 1, 2, 3, 4, 5, 6 and 7, 8. There are 8 channels here. So in our case, it is actually the 5th channel. So you can select, you can copy this to an Excel sheet, select it, then plot it. Okay, and you can get the waveform. So this completes our NRDE software familiarization. Now this is only one program of overcurrent relay. So we can have several such programs. Okay, we can have several such programs, and we can do steady state analysis for all of them, differential relay, distance relay, like that. Okay, so we stop here. Thank you.